Dryers are heated with steam. With increasing operating speed, the condensate follows more and more the dryer shell. This is shown in slow motion in order to understand it better. From a speed of approximately 400 meters per minute, it forms a water rim which is then stabilized at approximately 500 meters per minute. From now on, the turbulences in the condensate are reduced drastically and the heat transfer to the dryer is reduced. This negative development for the drying process, and in the end for paper quality, is prevented by the use of thermal bars. The newly patented thermal bars consist of light channel sections and preloaded spring elements. They can be mounted easily. Three-part retaining rings form a stable supporting frame. The spoiler bars are connected with the retaining rings by a positive locking without any screws or pins. The spoiler bars are prepared such that a retaining ring can be mounted every 150 millimeters. This permits a very variable arrangement of the retaining rings and adaptation to the different lengths of the dryers. The patented profiling of the spoiler bars prevents interdependent shifting in the dryer. For loading the thermal bars, the screws of the spring elements are removed. By this, the retaining rings press the spoiler bars against the dryer wall. The springs compensate for diameter tolerances of the dryers and also ensure that the varying thermal expansions caused during the heating up of the dryer are compensated for. The dryer can be equipped with thermal bars over its entire length in this easy way. If there is a groove, mini thermal bars are installed in the dryer in the edge area on the opposite side of the siphon. They prevent moisture edge strips from developing in the paper web in this sensitive area. From an operating speed of 500 meters per minute, the thermal bars ensure a constant movement of the condensate. The siphon and the thermal bars must be optimally matched to one another as the thickness of the condensate rim is influenced by the siphon. Thermal bars permit a permanently increased heat exchange and also help save energy, because due to the improved heat transfer, improved drying of the paper web can be achieved with distinctly less steam.